Hi, I'm Quincas and I'm a synth DIY guy. Today we're building a very special kit. This VCO is the first in Erica Synth's new line of educational module kits, the MK1 versus ES.edu. Erica has teamed up with one of my favorite synth DIY YouTubers, Moritz Klein, to create a whole system of kits with a focus on actually learning about electronics and understanding the principles that make these modules work. Each kit is accompanied by an in-depth manual with easy-to-understand schematics and circuit descriptions. In this video, we will build the kit, tune it, and use it to make some sounds. But you can watch videos by Moritz himself on the theory, as well as reading the manual, of course. You might even want to do some of the suggested breadboard experiments. The PCB even has a kludge zone, where you can implement your mods and improvements. So let's build it! The kit comes with everything you need. Just open the baggies and organize the parts on your work area. Start by measuring the resistors, then stick them where they go on the circuit board. Let's do that only to the ones that go on flat, not the standing ones just yet. When you see two pads very close together with one circled, that's a standing or TP resistor. We'll do those later. I like to measure the resistors because I can't really see the color codes very well, so sometimes I might get them wrong. So measuring them, I'm sure of the value. You'll notice the values are rarely perfectly round. These slight variations are perfectly normal. It's what is called component tolerance. Just round them up or down to the nearest value found in the build guide. We'll also plug in the two Schottky diodes, mindful of their orientation. Make sure the white lines on each diode line up with the lines on the silkscreen drawing. I like to solder the resistors from above. The holes on the PCB are plated through, which means they are lined with metal inside, so no matter which side you solder from, the solder will flow through to the other side. Once soldered, turn the board around to trim the leads. Cut right above where the solder joint ends. Then touch up the soldering with your iron to make sure there's not too much or too little solder. Now plug in the IC sockets, making sure the byte on each socket lines up with the one on the silkscreen. This will help make sure you plug the ICs in correctly later. I used the panel to hold both sockets in place while turning the board around to solder. Then I soldered just 2 pins for each socket and made sure the sockets were flush and flat on the board by pushing each socket in from below while reflowing the soldered pins. Then I soldered all of the other pins, careful not to create solder bridges or cold joints. Now let's install the ceramic and film capacitors. These are not polarized, so it doesn't matter which way they go. Just be sure to plug in the correct values in the correct spots. Bend out their leads from behind and solder them on. Then cut the leads. Next come the thermistors. These all go in a row and are not polarized. Now the transistors. Notice these are different. One is the BC548 and the other one is the BC558. I actually had to use my microscope to see which was which. Plug each one in its designated spot, matching the drawing on the silkscreen. Bend out the leads to keep them in place and solder them carefully, then trim the leads. Now let's plug in those standing resistors. Bend down a single lead and plug each resistor in with its body on the circled pad. Solder and trim the leads. Then install the electrolytic capacitors. These are the metal cylinders, and they are polarized. The longer lead indicates the positive side, and the white line on the side indicates the negative. Now, as you can see, I've moved on to the panel components. I seem to have forgotten the power header. I will have to remove the panel later in order to install it. Learn from my mistake and install it now before the pots and jacks. The skinny black pots are also called tall trimmers. These have different values. Make sure you place them in their correct spots. Once all pots and jacks are in place, you can slip on the panel and finger tighten some nuts to keep it all together. Check to make sure the trimmers are not rubbing against their panel hose, then turn it all around and start soldering. Now this is when I noticed the power socket was missing and proceeded to remove all knobs and nuts in order to remove the panel and install the socket. I hold the socket in place with one finger and use my snake charmer technique to solder just one pin. Make sure the header is flush against the board, then solder all the other pins. Make sure the small opening on the header faces outward from the PCB. This is crucial for the correct polarity of the power connection. Now you can snap the ICs into their sockets. From the factory, the IC leads are open a little bit wide, so I push them up against the panel slightly to straighten them out before plugging them in. Now I can put the panel back on, tighten all the nuts, install the knob, and that's it. Just check the power header for shorts and plug it in to test and calibrate. Okay, so let's have a look at how to tune this oscillator. So first you will need some kind of reliable volt per octave source. So I'm going to use my Endorphin's ground control here to generate C notes in different octaves, right? But you can use something like a KeyStep or a KeyStep Pro or a BeatStep Pro, any kind of controller that puts out 1 volt per octave CV or a MIDI to CV converter, anything like that. You will also need a tuner. I'm using my Mordax Data as a tuner, but you can use just a regular guitar tuner if you want. So what I'm doing is I'm sending the saw wave output from the VCO to the tuner, from the tuner to the audio interface here, so we can hear the note, right? And right now I'm sending it this middle C here, C4, right? So if I go up an octave, you should see another C, and we don't, right? It's low, it's a B when it should be a C. So that means we have to turn the module around and fiddle with the trim pot here, right? So if this oscillator is anything like others I have tuned in my life, then most likely we need to counterintuitively make it even flatter, right? And then what that's going to do is it's going to move that bass note even farther and expand the distance between the octaves. And that's what we want in this case. The octave is too tight. See? 1 volt is giving us a C to B, not C to C. So we need to open up that range. And yeah, it is counterintuitive, but in my experience, usually you make it flatter. So let's go see if now we have a, see, that C became flat as well, right? So now we can tune it up to a C again. I'm using the fine tune here. There you go. Put that back there. Now let's see that octave above. It's still a B, but it's closer. So I think we need to go a little more flat, which is, I'm turning it clockwise to get flat. See? Maybe that's right. That already sounds more like an octave to me, and it looks like an A sharp with few cents high. That's almost an octave perfectly, right? So let's go back to the middle C here and tune that back down to a C. This time I'm going to use the chorus tune control on the oscillator here, just because we're farther away. There's our C4 again. C4 there. Now if I play the octave above, it's still a little flat. So we're going to go a little bit flatter yet. And remember, that's clockwise. Okay. So let's go back to middle C here, tune that up. And now go up the octave. Still a little flat. So remember, counterintuitively, we want it to go even flatter. So a little bit more clockwise here. Let's go back to middle C, Tune that up and check the octave. And that's about right. It's fluctuating a little bit, probably because I have it out of the case and I'm interacting with it with my hands capacitance and such. Okay, so now let's try more than one octave, right? So we're gonna go down to C2 there. It's 2 octaves below. Tune that to a C. And now we'll go up 3 octaves or 4 octaves. 1, 2, 3, 4. Huh. Well, that's impressively accurate. It looks like with just that 1 octave adjustment, I kind of nailed it for up to 5 octaves. Let's see. Yeah, I think the tuner is having a hard time at that point. But let's see. SC3, C2, C1. Ah, look, C1's a little high. So why don't we use C1 as a reference now? So I'll tune it with the fine tune tall trimmer here. And now we're gonna go up all 5 octaves. 1, 2, 3, 4, 5. And see, it's a little bit flat, so we're gonna make it a little bit flatter. And back to that C1 there. And now up 5 octaves again. 2, 3, 4, 5. And now it's a little high. So that was too much. So now I'm going to go back. So that means make it sharper, right? So if it's sharp, you make it sharper. If it's flat, you make it flatter. And that's how you adjust the tuning. So now I'm going counterclockwise, making it a little sharper. Alright, so now let's go back 1, 2, 3, 4, 5 octaves. See? Ah, that looks perfect. Let's tune it to the middle there. A little bit. There it goes. About there. Now go up 5 octaves. 1, 2, 3, 4, 5. And yeah, that's good enough, really. And I can even go up 1 octave more. And that's when my tuner starts having a hard time. It sounds to me like an octave. So yeah. Now I can play melodies here. There you have it, a nice musical VCO in tune over more than 5 octaves. Let's hear that pulse wave. Nice. Let's fiddle with the pulse width here. Nice. Let's look at that in the oscilloscope. So I've got oscilloscope here and data as well. Let's make trigger into normal so that it kind of freezes there and you can actually see that pulse width. Alright, let's go up an octave. And watch as I turn the pulse width. Very nice. And in the other direction. So quite a bit of tonal variation in this such a simple VCO. Alright, so now why don't we plug this into a filter and use it to make a little music. Let's make it a little faster. Here's the post width. Very nice VCO. Why don't we connect this LFO to the filter here? This is giving us a random opening of the filter, but in time with our sequence. Let's make this octave lower. Buen bajo. Nice bass. Here's with the saw wave. Nice and squelchy. This is as good a VCO as any, honestly. It's in tune and the waveforms are good. No DC offset to speak of. Sounds great. So that's it for today. I hope you liked this oscillator. It's an oscillator. And I hope you learned a lot from building it. Make sure you learn from this one. This is definitely not a kit to just build and use. This is one to investigate, to try things, and learn from it. Maybe design your own stuff later with the knowledge that you gain from this project. So that's it for today. See you soon and stay noisy.